Hi, this is Mamachan Mukherjee and welcome to my YouTube channel I Love Electrical Engineering. Today I will discuss on electrical power transmission system. Electrical system is basically divided into three parts: first generation, second transmission and third distribution. If you see the diagram, then it will be clear that this is the black portion. If you see the black portion, that is called generation part. After generating the voltage or power at power plant, we have step up the voltage. Then we transmit the voltage through tower and other thing. This blue color portion is called electrical transmission system or electrical transmission lines. Then again we have step down and send to the receiving end or the customer. This green portion is called distribution system. So today we will discuss on this blue portion only, electrical transmission system. It means in this blue portion only. So what is transmission line? Electrical power transmission is a process by which electricity is transported over a long distance to customer. It means इलेक्ट्रिकल पावर लॉन्ग डिस्टेंस में वन एंड टू अनदर एंड 400 500 600 किलोमीटर जो भेजता हूँ इसको इलेक्ट्रिकल पावर ट्रांसमिशन बोलता है. द इंडिया ट्रांसमिशन वोल्टेज आर 33 kV, 66 kV, 132 kV, 220 kV, 400 kV, 600 kV, 765 kV generally, and 1200 kV substation we have constructed at MP Bina. The owner is Power Grid. The first and only one 1200 kV substation in India has already been constructed in MP Bina, but that is not so economical. So up to 800 kV we have used generally. The type of transmission line. Now I am coming to the type of transmission line. Basically, according to the voltage or according to the current, transmission line is two types: AC transmission system and DC transmission system. Now I am coming to the according to the circuit. According to the circuit, single circuit transmission, there is RYB, the three phase only. Double circuit transmission line, RYB and RYB. There is six conductor or two R phase, two Y phase, two B phase. And multi circuit transmission line, there is four circuits, six circuits, like that. Now I am coming to the what are the material required to construct a transmission line. Basically, to construct a transmission line, the below mentioned seven materials are required. First is tower, transmission line tower. Second, tower accessories. Third, power conductor. Fourth, earthware or OPW. And now today's date, use of earthware is going less, and use of OPW, optical fiber ground wire, is increasing day by day. Fifth is insulator. Sixth is hardware fittings. Seventh is accessories of conductor and earthware or OPW. For OPW, I will prepare a separate PPT and I will forward. Now I'm coming to the transmission line tower. According to basically transmission line tower are four type: A type, B type, C type, D type. This is divided according to the angle of deviation of line. If the angle of deviation of the line is 0 to 2 degree, then it's called suspension tower. If the angle of deviation is 2 to 15 degree, it's called B type tower, that is also tension tower. If angle of deviation is 15 to 30 degree, that is C type tower. It is basically used for tension tower, transposition tower or section tower. That is basically used for transposition or section. And D type tower, that is the angle of deviation is 30 to 60 degree. Basically this is used in dead end tower or railway crossing, line crossing, national highway crossing, etc. And some special type of tower also used, that is specially designed for special work like for critical area. Now I am coming to uh, the some tower sample of some tower weight and height. Basically, this is for wind zone 4. India has 6 wind zone. This is a lump sum idea, tower height and weight for wind zone 4. If you see the 400 kV tower, A type tower is basically 12 ton के आसपास इसका weight होता है. B type tower 17 ton, C type tower 18 ton, and D type tower approx 26 ton. And if you see the height, A type of 400 kV line, double circuit line. Basically, these are double circuit tower. D type. A type tower double circuit का height होता है approx 48 मीटर. B type 45 meter, C type 45 meter, and D type 47.48 meter approx. That is the approx height and weight of double circuit tower for wind zone 4. And India has 6 wind zone. This is the 6th wind zone in India. This depend wind velocity of 6 wind zone are 33 meter per second, 39 meter per second, 44 meter per second, 47 meter per second, 50 meter per second, and 55 meter per second. Now I am showing some picture of different type of towers. The first picture of 765 kV single circuit tower. Second picture is 400 kV single circuit tower. Next one is the 400 kV double circuit tower, and last one is 400 kV multi circuit tower. And if you see some special type tower, these are for river crossing or for critical area crossing. We have used and specially designed a special type tower. And this is DC transmission line, DC tower. The Indian highest DC transmission voltage is 600 kV. Now I am coming to the tower accessories. What are the tower accessories? Basically, there is 7-8 accessories are required for tower. What are that? The danger board, number plate, face plate, circuit plate, anti-climbing device, bird guard, span marker, and tower earthing. For tower earthing, there is required tower electrode, one of GI electrode, and GI flat. Basically, two type of earthing are used in transmission line tower. One is pipe type, and second one is counterpoise type. Depend on the fall resistivity. This is number plate of a tower. If you see, this is number plate. Next one, if you see, this is bird guard. This one is bird guard. Bird guard is used basically if बर्ड ने मैंने पाखी ने उसमें कुछ बासा फासा ना बनाए, कुछ फॉल्ट बनाए, इसलिए इसको यूज़ करना पड़ता है. एक कराफ्ट टाइप का देखने में लगता है, इसमें बर्ड नहीं बैठता है, सब काट जाता है बोल के, तो इसको बोलते हैं बर्ड गार्ड. Now I'm coming to the transmission line conductor. What are the conductor used for transmission line tower? Different voltage level. If you see the basically triple AC or ACSR, maximum time ACSR conductor is used due to his highest tensile strength. For 765 kV we have used Barsimis conductor. For 400 kV we have used Moose conductor. For 220 kV we have used Zebra, and for 132 kV we have used Panther. For 33 kV we have used Wolf. Basically all conductor name is expressed by animal name. Is standard by the electricity board or electricity committee. This is the sectional view of a conductor. Now I am coming to the insulator part. The insulator is two things. First is how much number of discs is to be used according to the voltage level. according to the voltage level, different number of discs is used, and the tensile strength of the discs also differs according to voltage level. If you see the 132 kV, we have used 45 kN discs. For suspension, we have used 9 discs, and for tension, we have used 10 discs. If you see for 220 kV, we have used 70 kN discs. For suspension, we have 13. For tension, we have used 14 discs. For 400 kV, we have used 120 kN discs. 120 kN means kilonewton is tensile strength of the discs. So 400 kV we use 23 number for suspension and 24 number for tension. For 765 kV also we have used 40 number discs generally. This is a single suspension string. Its single suspension string looks like that, and if you see, this is double tension string. Double tension string look like this. And this is also single suspension insulator string with quad conductor, with twin conductor. This is a double suspension insulator string with 6 conductor, hexa conductor. Now I'm coming to the hardware fittings. What are the hardware fittings is required for this insulator or to springing the conductor and all this, the fittings the conductor? Single eye suspension insulator string, double eye suspension insulator string. I have already shown the photo of the same. Single suspension pilot insulator string, double tension insulator string, and double tension insulator string. I think that it is already cleared from my previous photos. Now I am showing some photos of hardware fittings of 1200 kV voltage level. It is just number of discs is not showing according to the 1200 kV. Only I am showing the how to see the hardware fittings for 1200 kV voltage level. Now I am coming to the accessories of conductor and earthware. What are the accessories required for stringing conductor and earthware? Basically, these 9 uh, equipment accessories is required for conductor and earthware. What are that? Mid-span compression joint for conductor, mid-span compression joint for earthware, T-connector for conductor, repair sleeve for conductor, flexible copper bond for GS earthware, vibration damper, spacer damper for conductor, rigid spacer for jumper of conductor, tension clamp for earthware. Basically, mid-span compression joint is used to joint conductor in the conductor drum is joined in a middle of a span. Basically, to join two part of conductor. Similarly, earthware, mid-span compression joint for earthware also is joined to earthware. Repair sleeve, basically if any one or two string is damaged of conductor, we have used repair sleeve. Flexible copper bond is used for earthware to connect with tower. Vibration damper is used in earthware and as well as in conductor to reduce the vibration. Minimum vibration कोई vibration pass ना करे tower में, from conductor to tower vibration minimum to minimum pass करे, इसलिए we have used vibration damper. Then we use spacer. Spacer is generally we have used to isolate the conductor of the same phase. Suppose we have used twin conductor, then we use spacer for twin conductor. Suppose we quad conductor, then we use spacer for quad conductor. And tension clamp for GI earthware, that is used for one tower to second tower to joint earthware. Now I'm showing some photograph of different hardware fittings, all these things. This is suspension and tension type clamp, and second picture is showing some desackle, hanger, and etc. This is called PG clamp and others clamp which are required basically. Now I'm coming to the construction part. What are the construction activities or construction part of a transmission line? There is just 11 part. Basically, if you divided the total line, there should be minimum 11 part to construct a transmission line. First is selection of route. Second is preliminary survey. Second, third is approval of clearance for the line's route. Fourth is detailed survey and piloting. And fourth is detailed survey and plotting profile. Fifth is check survey and location marking. Sixth is checking right of way. Seventh is stop setting. Eighth is erection of tower and fixing accessories. Nine is stringing of conductor and earthware. 10 is stringing of protection of tower footing and etc. मतलब protection equipment. And 11 is testing, commissioning and charging. Now I'm coming one by one. What are the criteria of route selection? First I am coming to the route selection. What are the criteria of the route selection? Route should be shortest length, hence least capital cost. जितना छोटा रूट होगा उतना उसके लिए कॉस्ट कम होगा. रूट नियर द रोड फॉर इजी अप्रोच एंड एक्सेसिबिलिटी. फ्यूचर मेंटेनेंस के लिए लाइन के पास साइड में रोड रहेगा तो उसका मेंटेनेंस करना भी इजी रहेगा. Required separation distance from communication line and railway lines. Railway and communication line से एक minimum clearance distance maintain करना पड़ेगा. Requirement of future load substation near area. The proposed route of the line will be easily connected. In future जिस एरिया में सबस्टेशन बनेगा व कुछ बनेगा उसी एरिया का थ्रू लाइन को जाना चाहिए, क्योंकि बाद में उसमें से टैपिंग करना व लीलो बनाना बहुत इजी हो जाएगा. Maintaining statutory distance from airport and helipad, maintaining sufficient margin from towns and villages, avoid forest area जैसे ज़्यादा पेड़ ना काटना पड़े. This is for environment issue basically. Now I am coming to the some criteria for crossing of different things like railway, like communication line, power line, etc. The railway line crossing के लिए we should avoid platform and traction substation. We have to cross the line at 90-degree angle. We will have to try to cross the line by 90 degree, not less than 60 degree, and the general span should be 80 degree. 80% of the basic span. General span should be 80% of the basic span. Crossing of telecommunication line also same. It should be 90 degree. Communication line को भी 90 degree cross होना चाहिए, not less than 60 degree. Crossing of power line crossing के लिए एक वोल्टेज लेवल से सेकेंड वोल्टेज लेवल के अंदर एक मिनिमम डिस्टेंस रखना पड़ेगा एज पर इलेक्ट्रिकल नॉर्म्स, इंडियन इलेक्ट्रिसिटी एक्ट. एज पर इंडियन इलेक्ट्रिसिटी एक्ट वोल्टेज एक गेट वन गेट वोल्टेज टू अदर वोल्टेज से अंदर मिनिमम डिस्टेंस मेंटेन करना पड़ेगा. एंड हाई वोल्टेज शुड बी ऑलवेज इन द टॉप. हाई वोल्टेज सब समय ऊपर में रहेगा. एंड क्रॉसिंग शुड बी डन एज पॉसिबल 90 degree. रोड क्रॉसिंग ऑल्सो शुड बी डन 90 degree% जाते मिनिमम क्रॉसिंग है. रिवर नाला में भी सेम होता है, 90 degree में क्रॉसिंग करना पड़ता है, जो मिनिमम टू मिनिमम डिस्टेंस लगे. नाउ आई एम कमिंग टू राइट ऑफ वे. फॉर 132 kV वी हैव रिक्वायर्ड 27 मीटर राइट ऑफ वे. मतलब हमारा जिस रूट में लाइन जा रहा है उसका 27 मीटर विथ पूरा क्लियर होना चाहिए, उसका आसपास में कुछ भी नहीं रहना चाहिए. फॉर 220 kV लाइन 35 मीटर, फॉर 400 का 52 मीटर होना चाहिए. Now I'm going to detail survey and plotting profile. For voltage level, different voltage level span is different. I am giving some example. For 132 kV span require 35 meter, 335 meter. For 220 kV standard span length is 350 meter. For 400 kV standard span is 400 meters. That is maximum standard length. Sometimes we have to use below this short length also, depending upon the route and all these things. And the minimum ground clearance we have to maintain for 132 kV, we have to maintain at least 6.1 meter. For 220 kV, we will have to maintain minimum 7 meter ground clearance. For 400 kV, we will have to maintain 8.84 meter ground clearance. And for 800 kV, we have to maintain 12.40 meter ground clearance. This is as per Indian standard, as per IS. Now I am coming to the minimum clearance required for one system voltage to another system voltage crossing as per Indian Electricity Act 1956. If you see 132 kV crossing के लिए कोई भी लाइन 132 kV up to 132 kV और below voltage line में 3.05 मीटर. For 220 kV line और below line के लिए we need at least 4.58 मीटर. For 400 kV or below line crossing के लिए we have required at least 5.59 meter, 5.6 meter. 800 kV or below voltage के लिए we have required 7.94 or you can say 8 meter. This is a sample of plotting profile. Through this we have checked the clearance and all these things. Through this plotting profile, we have a plotting profile equipment. Through this we have checked the ground clearance and all this crossing and others through this sample ground profile. After preparing that, we have to take approval from the authorized body. Now I am coming to the foundation and stop setting. Basically, foundation of tower is depend on the type of soil. The different type of soil are like dry type soil, wet type soil, pasture is depend on the water level of the soil, and for different type of soil the foundation also is different. So basically, first we have done before start the foundation, we have done the pit marking like that. After pit marking, we have dig the peak. After dig the peak, we have set the stub through templates. Then we have done the concrete and tower foundation for each layer. This is the picture of stub setting, stub template setting, and RCC of stub. Now I am coming to the erection of tower fixing accessories. Basically, tower shall be erected on the foundation not less than 14 days for if OPC has been used, and not before 21 days if PPC cement is used. PPC cement means pozzolana poldent cement, OPC means ordinary poldent cement. Ordinary poldent cement में फ्लाइस नहीं रहता है, PPC में फ्लाइस रहता है. टावर एंड स्टाफ मटेरियल जनरली GI का होता है एंड HT स्टील, MS और HT स्टील डिपेंड ऑन द स्ट्रेंथ. तो टावर जो इरेक्शन होता है थ्री टाइप में इरेक्शन करता हूँ. एक बिल्डअप मेथड, एक सेक्शन मेथड एंड वन इज ग्राउंड असेंबली मेथड. तो बिल्डअप मेथड हम लोग क्या करता हूँ, बिल्डअप मेथड में 1 बाय 1 मेंबर को हम लोग स्टाफ इरेक्शन हो जाने के बाद, स्टाफ फाउंडेशन हो जाने के बाद 1 बाय 1 मेंबर को हम लोग नाट बोल्ट से टाइट करके इरेक्शन करता हूँ. सेक्शन मेथड के टावर का एक एक पार्ट को ग्राउंड में असेंबली करके उसको क्रेन से उठा के एग्जिस्टिंग टावर के साथ हम लोग उसमें कर देता हूँ. एंड ग्राउंड असेंबली मेथड में पूरा टावर को ग्राउंड में असेंबली करके उसको स्टाफ के ऊपर खड़ा करके हम लोग नाट बोल्ट से टाइट करके टावर इरेक्शन कंप्लीट करता हूँ. एंड इफ यू सी द फोटो, दिस इज द बिल्डअप मेथड. बिल्डअप मेथड में 1 बाय 1 मेंबर को हम लोग फिक्सिंग कर रहा हूँ. दिस इज द सेक्शन मेथड, मतलब एक एक सेक्शन को नीचे करके क्रेन से उठा के हम लोग डालता हूँ टावर के ऊपर. एंड दिस इज द स्ट्रिंगिंग ऑफ इंसुलेटर. बेसिकली टावर इरेक्शन के बाद इंसुलेटर स्ट्रिंग को नीचे बना के टावर में फिक्स करना पड़ता है थ्रू हैंगर और डिसकल. Now stringing of conductor and earthware. How to string conductor and earthware? I am going to that. द कंडक्टर स्ट्रिंगिंग ऑपरेशन इन्वॉल्व पुलिंग ऑफ द कंडक्टर। हम लोग क्या करते हूँ, पहले टावर रिएक्शन हो जाने के बाद हैंगर और डी साइकिल से इंसुलेटर स्ट्रिंग को हम लोग हैंग कर देता हूँ। उसके बाद हर इंसुलेटर स्ट्रिंगिंग में हम लोग पुली लगा देता हूँ। पुली पुली से पायलट रोप के रन करता हूँ। पहले पायलट रोप के रन करने के बाद हम लोग टेंशन स्ट्रिंगिंग इक्विपमेंट का थ्रू कंडक्टर को टेंशन देता हूँ to get the proper sag or to get the proper tension from tower to tower of conductor. Now coming to the testing and commissioning. Testing before line charging, we'll have to check insulation resistance check by Megar, and conductor continuity test. Basically use Wheatstone bridge or other any equipment, and we have to take clearance from railway authority, from power and telecom line coordination committee. It's called PTCC. PTCC clearance have to take, and electrical inspector clearance, CI, chief electrical inspector clearance. We have to take these three clearance, and after that, if all are okay, if the insulation level is okay, if conductor continuity is okay, if I get all these three clearance, then we can charge the line. And that's all about the transmission line. Thank you.